So welcome everybody, and I want to welcome Chris Lasch, who's part of the duo Aranda and Lasch. I think what we're being presented with tonight is one of the true originators of the ever-expanding realm of computational design and architecture. Tonight we are really at the source of it all, in my view, an advent of the relationship between architecture and scripting, and algorithm, recursive geometry, so on and so forth, in numerous ways which we describe it. Ben and Chris were scripting before Grasshopper, right? So there was a land before Grasshopper, non-visual scripting. And I would say that to a greater extent, they were the people that propelled programs like Grasshopper and various other computational design tools into the popularity that they exist today. These are the people who are, to a great extent responsible for so much that's going on in terms of innovation in American architecture schools today. Aranda Lasch is a design studio that's dedicated to experimentation, research, and innovation in buildings. They were established in 2003, and a lot of their work began with installations and furniture and the study of objects. They've been winners of the United States Artist Award and Young Architects and Designers Award in 2007, the Architectural Record Design Vanguard Award in 2014, the Architecture League of Emerging Voices, and it goes on. Their early projects were subject to the best-selling book Tooling, which many of you will recognize. And they've exhibited their work internationally in galleries and museums, design fairs, and architectural biennales. It goes on. They're currently emerging as architects building grown-up buildings as well, not to denigrate earlier work. Just completed the Tom Ford flagship in Miami and Florida. They're working on an extraordinary project in Gabon, an art park and museum in Bali and in Indonesia, and that list goes on and expanding. They're currently preparing a large exhibition in Tucson in Arizona. I asked Chris I said, well, what about publication? So he sent me, just recently sent me through a list of publications. And that runs to 2 pages in like a font that's about 8 point. Right, so there's no way I'm going to read it all out, but I'll just read it. That goes recipient, recipient, third place, winner, recipient, recipient, winner, recipient, finalist, winner, winner, recipient, finalist, and that's just awards, right? And we're talking about places like, we're talking about, international competitions, not talking about chopped liver, so they have an incredible pedigree of achievements, both in competitions, in exhibitions, and then in publications as well. So their list of accolades just goes on and on. So I would like to just to conclude the introduction by saying that quite often I find that the criticism of Aranda and Lasch's work is that is presented as the alternative to something which is collaborative, because there's such an inherent formal sophistry to it. It gets denigrated for being pure formalism. Now, I know these two architects very well. I know how much more complex their work is than that can be placed within a binary or dialectic opposition. One shouldn't presuppose that having a strong formal language makes it inherently either anti-social or anti-collaborative. And arguably, that comes from a non-architectural form, kind of stoicism, in a way. It's much more cerebral than that. We don't want to reduce ourselves to an over-chastened kind of culture of architects that don't appreciate visual sophistry and material forms as an alternative form of architectural language, and not overly categorized. So it's my great pleasure to welcome tonight Chris Lasch as part of Aranda and Lasch for our lecture. Thank you.
Can you hear me okay? Well, thank you, Jason, for that very generous and hastily prepared introduction. And thank you very much to the school for having me here. It's great to be here. Thank you guys all for coming out on a Friday evening. What I wanted to, Jason kind of set up what I was planning to talk about tonight. I wanted to talk about the computation and ruin. And in that, I want to look back over, say, the past decade or so of our practice and reflect on some of the themes that seem to recur in our work. I'll try to draw out some of these themes and talk about them. And then I'll end by showing how these same themes are at play in our current projects as we move into larger and more built type of work. And I'll especially focus on how we've used computation as a way to generate and manage the design information in our projects. These are just some kind of cascade of images from some of our early work, and they kind of start to see some of these strands of research within the practice that I want to call out. One is the quasicrystal as a notion of an endless structure. The fractal as a scalar system, and the single building element as a way to make structures with a radical kind of modularity. But also, looking back at our work over 10 years, there are other surprising patterns that began to emerge in our practice, and it wasn't entirely obvious to us at first what they were. But it's not just about patterns and math and assembly, although it certainly is about that. But it's also about history, and it's also about stories and storytelling. There seems to be a certain obsession with the historical object and a way of kind of reaching back as a way to move forward. So I guess while we certainly have an obsession with systems, it's also coupled with an insistence on keeping these systems open, so that the projects can kind of blend in with the world around them and with other interests that connect them to our everyday life as we live it. So I want to just go really quickly through a number of early projects that start to talk about this, started to talk about how history is a generative force in our work, starting with this one. This is the grotto, which was a very formative project for our office. It's about how to make a fake cave in the landscape. This was our unsuccessful entry to the PS1 Young Architects competition, which is a competition to design a summer party, a kind of party space in Queens. And we chose the grotto as a format to work with. And we wanted to really find a way to kind of siphon into it some of the lost enchantments of romanticism that are trapped in this archetypical landscape device. And the challenge for us was really how to release this Victorian romanticism through procedural design and through our own obsession with boulders. So here you can kind of see the space of the project being built up using just 4 modular boulders, ultimately to create a kind of new landscape within the courtyard of the museum. Another early project entitled 1774, which is the year that Louis XV died. And this is the fauteuil chair attributed to his reign. 1774 was also the year that the trace element manganese was discovered. So this time using a single element, a single shape, we built up this project that was, in a way, not so much about making it the chair itself, but rather about kind of rebuilding this moment of history from these two related events. And if it's not a direct time in history, sometimes it's about building things that continue a narrative. And we think that some of our greatest storytellers are scientists. like this guy, Daniel Sheckman here, where he's demonstrating the existence of something that heretofore was thought to be impossible to exist. He's talking about, he's demonstrating the existence of the quasicrystal, which is a type of solid material that has an aperiodic lattice, an unusual structural pattern, which fills, unlike common materials, it fills space in 3 dimensions, but it does so without ever repeating the same pattern twice. And while this had been demonstrated mathematically in the past, it was assumed to be impossible to actually exist in nature. But here, the proof is in the pudding here in these X-ray diffraction photographs that he took in the lab of a material that he had made. And here he's pointing to an icosahedral model that points to the kind of brilliant simplicity that this endless and non-repeating structure is actually made up of just a couple of basic shapes. So Sheckman's story is a kind of modern search for the endless or endlessness. Recently, more recent than Sheckman's work in the mid-'80s, we've discovered that this kind of quest for endlessness in design has been demonstrated a lot further back than that. This is on the right is here is the nave of a mosque in Isfahan, Iran, where also that also displays this kind of icosahedral high order symmetry tiling design that forms a non-repeating pattern. This is a table that we did in 2006 or so, and we really see our work as kind of belonging to this legacy, this kind of search for endlessness. And many of our efforts along these lines revolve around making universal things like this very specific. We ask ourselves, how can we tell these cosmic stories through something, through quite mundane things like a table, or like a mirror, or a cabinet. In this project, the connecting the past and the present was explicitly the kind of generative formulation of the project. This is a collaboration that we did with a Native American basket weaver called Terrell Dew Johnson, who hails from Sells, Arizona, about an hour southwest of Tucson. And together we set out, this is Terrell here, together we set out to kind of explore our 2 practices' shared foundation of pattern making through procedural design for an exhibition at New York's Artist Space in 2006. Through a conversation around the algorithm around weaving, we produced a number of different pieces that kind of blended our 2 practices. So this is, again, a kind of coming from a tiling logic, but this time being expressed with loops. Back in 2006, we and others were trying to figure out. We were playing around with algorithms, and we were trying to figure out how we can incorporate algorithmic techniques, scripting, into a kind of otherwise conventional design process. And back then, the conversation, when it was talked about, it was always talked about as something very new. But with what this project taught us, working with Terrell, is that algorithmic design is not really new at all. That it's you can see it in the foundation of one of the world's oldest material practices, in fact, which is weaving. And that for us, it became a lot more useful to recognize our work as part of a rich design tradition, a rich tradition with very kind of ancient roots. I mean, I think Nick Alt made this point in his presentation today, that this stuff is not new. It's part of a kind of legacy that goes way back to the very foundations of material culture. And we second that emotion. In fact, three of the pieces from this project last spring were collected by the Museum of Modern Art in New York as an example of this kind of continuity through material culture. And this is in the fall of this year, we're going to reprise our collaboration with Terrell for a large exhibition in Tucson, Arizona, where we'll make some more baskets. We're going to play around with mud and Adobe for doing some building on the reservation, and try to draw out some of these connections between a kind of craft practice and its connection explicitly to the kind of mathematics and science as an educational effort through the development of a makerspace on the Tohono O'odham Nation, where we hope to kind of reveal to the kids on the reservation what we discovered in this project, that when things like algorithms and procedures and mathematics that oftentimes seem pretty abstract kind of come alive through familiar objects, through familiar formats, like making a basket or tiling a wall. Another project for the MoMA, I'm going to speed up here, is a commission that we produced a couple of years later for an exhibition called Design in the Elastic Mind for Paola Antonelli, and it was really about this guy here, Wilson Bentley, who was not a scientist but was a farmer in Vermont, who proved with his homemade camera here that no two snowflakes were alike. He went out there in the blizzards and photographed over 6,000 specimens across his lifetime, and he was the guy that proved finally that he's actually the guy that proved that no two snowflakes are alike. And as a kind of reward for his effort, he died of pneumonia in the snow. He was fascinated by the fact that all of them can be so different and so similar but yet so different at the same time. They were all different, but each was a crystal fractal with 6 and only 6 sides. So this piece is really a kind of ode to Wilson Bentley, and we made this design application in processing with the driving rule of 6 for Wilson Bentley, for this farmer in Vermont, who asked in a contemporary publication at the time, he was asking they didn't have a kind of working model of the atom at this point. It was right around the turn of the century, the last century, the 20th century. He asked, what magic is there in this rule of 6 that makes the snowflake conform so rigidly to its laws? I mean, he was really looking for rules. He was looking for order. He was looking for algorithms. This is a collaboration with the artist Matthew Ritchie, who is a painter, but for this project wanted to tell the whole story of the universe through just one part of it. The morning line is it's a fractal building system, again built from just a single shape, but this time the shape is inscribed with a collection of the artist's drawings. And the drawings come together to kind of make a picture and to tell a story, kind of three-dimensional drawing in and of space. It's a fractal story built up by a fractal that would change and reorganize itself depending on which city it was installed in. In addition to being a kind of three-dimensional drawing, it's also a sound pavilion. So within each scale of the structure, there's a different class of speakers. And it can be controlled. There's guy from the University of York wrote an application, Max MSP, where you can control how the sound moves through this thing. You can essentially play the sculpture like a musical instrument, and with this three-dimensional constellation of speakers, move sound around in space. And so wherever it moved, it would be put together. It's totally modular and disassemblable. So it would be put together in one place, taken apart into individual units, and put up somewhere else in a slightly altered form to resonate with the new space, and to kind of tell different stories based on how the drawings are put together and where it's installed. And so it started in Spain, went to Istanbul, as you could see. This is in Vienna, and now it's in the permanent collection of the ZKM in Karlsruhe. We've continued this to explore these narrative systems with Matthew. This is for an installation at the Andrea Rosen Gallery in New York last year, where we, again, accesses this kind of modular system, modular polyhedral system with 3 different kinds of looping surfaces as the surface for the inscription of the drawing. But this time, it's just a kind of different expression of that underlying geometry. And some shots of the fabrication in Tucson. Okay, and in this project, called 20 Bridges, it was a project where we multiplied Olmsted's bridges in New York, in Central Park in New York, creating new ones that make kind of new connections across the park. So all the stuff that I was talking about in the beginning kind of comes together in this project here. The quasicrystal, the fractal, the single building element, and the historical object. So all of our work is kind of in this image here. And it forced us to ask some questions like, what good is computation when it leaves something so atomized, so frayed, so kind of difficult to work with at times? What is it about computation that compels us toward entropy? How did computation get us here? Why is it that time and time again we start with an object of historical significance and we end up with a pile of ruin? Because we believe that computation is destructive to the discipline of architecture in a good way, in that it breaks things down to the smallest parts into a binary language of recomposition that opens up opportunities for new forms of equilibrium. An image that we like to use is sand. Architecture has kind of responded in every conceivable way to this breakdown. Like sandcastles hit by waves on the shore, this stable structure of architecture strives to control its dissolve, always with things like science, like parametrics, like algorithms. And with so many in the field today fascinated by technologies of assembly, numerical control, dynamic networks, it's hard to deny a strange dual obsession with the way that things stay together and the way that they fall apart. We remain transfixed by the tower and the ruin, sometimes at the same time. Architecture has actually been here before, and as with other times in history, the ruin is a soft foundation upon which to build the future. Here's a ruin, here is the future. Here's an image of the future as a ruin to learn from. This is a painting by a New Zealand painter called Gustave Doré, an architect from the New World. In this image, he sits to sketch the old world of London in ruins. Just as Britain was once a Roman territory and London architects learned from the ruins of Rome, it was imagined that someone from the new territories like New Zealand eventually would come and come to learn from the glorious remains of London. It's kind of like history, the future as a history that's repeating itself. We think it's interesting that precisely at the dawn of the last industrial revolution, radical architects, also like John Soane, demonstrate in remarkable and imaginative ways how their work is both a tower and ruin at the same time. Here, he's showing his design for the Bank of England in both a state of new and decay through this novel way of drawing the cutaway section. Or like Piranesi, who formed vital new structures from the fragments of previous civilizations. Piranesi was a major influence on Soane. Like sandcastles growing back onto the shore, he conjured these wild new possibilities from the rocks that he found in the ruins of Rome and Pompeii. These drawings of ruins both reproduce buildings that once existed, but also they led to breakthrough contemporary projects. And how these early studies of ruination became a system of formation and how they helped architects rescue their discipline from an overbearing classicism is a lesson, we think, that today's architects can take into the future. As we're faced with kind of increasingly overbearing modes of technology, we find that we are continually challenged to come up with ways that we can keep things open and explorative. And this is gives us inspiration on this quest. So here you have the architect then, kind of on the grand tour, measuring a ruin with a measuring stick, and the architect now. This is our office in New York. The architect now is kind of always in front of the screen. And so we pair these images together to draw a kind of parallel that working with computation, the reorganization of parts, the relationship of the parts to the whole, is reminiscent of this 19th century neo-Gothic working with fragments of antiquity. The recursive modes of drawing, the extrapolation of a part into a whole form a kind of protogenomic project that foreshadows our work today. In other words, computation did to the physical world what time did to the ruins. The ruin was a kind of freedom to rebuild, and computation is giving us the same. And this is the drawing that started this whole line of inquiry for us. It's Henry Lebroust's imaginary reconstruction of an ancient city, undated. But looking at this, you have to wonder how Lebroust imagined this reconstruction, this whole city from a pile of rubble. Or to put it differently, you can think of how did the ruin know how to live again? What imagination is there in the hand of the architect, or in the matter of the brick itself that rebuilds itself? This question of how matter can organize itself happens to be a vital and productive question in material science today, and it's radically transforming our lives. The battery in your cell phone, the chip on your computer, devices talking to one another, all of this is possible because of a reinvention in materials and how they guide energy. And this reinvention of materials is radically transforming our culture, and this reorganization of material at the molecular level is part of what's driving our research. If humankind defines itself always by the materials that drive its civilization, the Stone Age, the Bronze Age, the Industrial Age, and more recently the Silicon Age. The Silicon Age is now ending, and the coming age is the Nano Age. It's an age of molecular control, an age where structures and materials are grown instead of sculpted, and top-down notions of form are being replaced by bottom-up rules of formation. In material science, this is referred to as self-assembly, a phenomenon describing how energy input causes a reorganization of molecules into new structures all by themselves. So these are just a kind of cascade of projects and experiments that illustrate how ways where we're trying to kind of confront this breakdown. And I just want to conclude with a section on how this idea of atomization and building back up that we saw in the kind of early projects is now informing our design process as we move into larger and built projects. This is the project that Jason mentioned, the flagship store for Tom Ford in Miami, which opened in December of last year. And the design taps into Art Deco from Miami's dynamic architectural past as a way to propose something contemporary. Art Deco in Miami is kind of characterized by these fanning motifs, which we always thought were very beautiful and also a very kind of effective way to engage the tropical sunlight in Miami. Our version over here is a textured concrete facade with this kind of pleated ripple that cascades down the facade to frame the storefronts and to dramatize the play of light and shadow in Miami's tropical sunlight. But this time with kind of more algorithmic rhythm and through a high-performance material system. The panels are produced with GFRC, which for the students in the audience stands for glass fiber reinforced concrete, which means that concrete is great in compression but lousy in tension. So typically what you do is you have rebar mixed in with the concrete, and that takes care of the tensile forces that are moving through the component. But the downside is that it means that the most elaborate shapes that you can make with the concrete pour are limited to how you can bend that rebar. So in a glass fiber reinforced concrete, chopped glass fiber takes up the tensile portion, and it's chopped up and mixed in with the concrete itself into this slurry. And here's the fabrication facility outside of Dallas in Texas in this huge repurposed like World War II hangar where there's a central kind of concrete sprayer moves up and down the length of this building, making all these pieces of other buildings inside of it. This is our mold. It was a modular mold where the shape of the shingles was built out of MDF, and then just by changing the gates on one side and the other side of the panel and reconfiguring the placement of foam positives for reveals and bigger ones, which will become places for lights to go, you can reuse this mold over and over again to make a variety of panels. These are some images of the installation of the panels. So we wanted to use GFRC because we needed something light enough to act as a facade element, but yet tough enough to stand up to Miami's hurricane codes. And in fact, there's a fiberglass mesh right under the surface of the concrete that helps protect the building from impact damage from debris whipped across the city from a hurricane. And so the idea was to, in a way, design these tiles in such a way that, like the earlier projects, we could use just a few tiles, but when they come together, they're greater than the sum of their parts. So from just a few tiles, you can put them together and make something that looks more or less like a continuous and random surface. Here's a detail of some of those light reveals. An image of the corner. The building is kind of deceptively complex because of the corner condition, where you had to allow for vehicular, you had to be able to see around the corner, while maximizing the space on the interior for the retail program. Some of the storefronts down the street. Yeah, so you can kind of see it. It actually like kind of gently leans over the sidewalk and out across, out over the corner, out over into the intersection with this big concrete prow. So that it's really So this opened just in November of last year, and we kind of consider it our first real building, our first ground-up building. But another one that we have on the way, it's just in the early stages of design now. And it's a project where we're attempting to blend art with landscape for an art park set within the agricultural rice paddy landscape of Bali that you see in this image. This is the site, just north of, up the river from Bali's capital city of Denspar. So our building is going to go kind of right around along this ridge. And you can see it here. The client is the entrepreneur and philanthropist Budi Tech. And this will be a new outpost for his Use Foundation, which is an art foundation dedicated to the collection of very large indoor and outdoor contemporary art pieces, and also for promoting a kind of cultural understanding between China and Indonesia through art. And this project is in his kind of home base of Bali, and will become the permanent home of the Use collection. And the nature of the collection is indoor and outdoor. So this project is planned as a kind of circuit through the landscape, where you moving indoors and outdoors at different times across this site, which is framed at the top by the rice paddy landscape and at the bottom by this river. And the pedestrian path will lead you around because of the kind of ancient and idiosyncratic nature of the property rights around there, and very rare and expensive property. He's been able to cobble together plots like here and there that are connected in a very kind of weird and meandering fashion. So the experience of the museum takes the form of a kind of meander. And along the way, this is the kind of art that you'll experience. This is the Use Foundation's collection of very large-scale art by international artists, a lot of Chinese artists, Sang Wan, Ai Weiwei, but Europeans as well, like Anselm Kiefer, Mona Hatoum. The kind of starting point for the design of the museum is for it to have a very kind of low profile and be more or less seamless with the surrounding context. So we started with a kind of quadrilateral tile that is reminiscent of the quadrilateral rice paddies that continue up the mountain, up the hillside, up to the central kind of reservoir, which is here at the very tip top of the mountain that is the island of Bali. And our site being between the rice paddies, which are flooded for much of the year, and the kind of main drain to this river down at the bottom of our site. Our building is imagined and actualized to participate in the kind of the local watershed of the site. So through this tiling logic, we're kind of extending the rice paddies out down the hill and creating, in effect, these art paddies, which become a kind of rooftop sculpture park over the kind of largest exhibition space on the site. So the inhabitable roof allows visitors to have a kind of continuous stroll. Sorry for the compression on this image, where you can go directly from the rice paddies onto the museum's display pedestals. So the museum is essentially designed to be experienced as a landscape, with the roof creating the sculpture park on the outside and filtering light into the interior of the exhibition space through a series of skylights here. And here you can see the interior kind of tiered gallery space where you're underneath the rice paddies. If the roof is imagined as an extension of the rice paddies down to the ravine, then the interior of the museum is imagined as a kind of molding of the hill, tiered down from that top of the hill out to a kind of exit entrance on the bottom of the hill that spills you out into the valley, where you can continue on seeing the rest of the site. There's a plan where you can see those tiered sculpture galleries kind of digging into the hill. This is an early structural sketch. We're working with Daniel Bozia of AKT2 in London, where we can see the art paddies developed into a kind of structural field of concrete units, either precast or cast in place. We don't really know yet. The corners of the quads are developed into columns and beams that support the slab of the roof garden above. So they're pinned together into this kind of structural tiled network. And together, each one forms a structural unit that tiles together with other tiles over the ravine to create a kind of even more artificial paddy landscape, but this time for the display of art. If the kind of rice paddy landscape is already a deceptively artificial landscape, this kind of extends that trajectory. So each paddy then becomes a kind of structural and display unit that can be tiled together to kind of extend or contract the space of the museum, adapting on the edges to interface with the existing landscape. And then a shot of the project at night where it transforms into something else. And part of this project is the residence. The residence portion of the project also reflects this dual nature of the owner. The Budi Tech himself is Indonesian and Chinese. And this aspect of being both inspired his collection to be about dialogue. And the residence, too, tries to bridge these two worlds. So the residence combines these two vernaculars, the Indonesian and Chinese residential vernaculars, where in the Balinese house compound, each room is a kind of separate small building, arranged informally and dynamically across the site. And in the Chinese courtyard house, rooms are adjacent to each other and arranged symmetrically around a communal courtyard. So the combination of these two vernaculars results in a system that adapts to both the local environment and the owner's personal cultural background. So it was important that the residence be designed as a kind of prototype. So we developed a modular system that can expand, can be expanded to expand the house and to add new ones as the foundation grows to include guest accommodations in the future, where people will kind of come here as an art pilgrimage site along the model of Emo Team in Brazil, or that one in Japan. What's that one called? Nawashima. It's beautiful. So the house is based on this kind of nested quadrilateral unit, similar to the one that structures the exhibition space, but different. And so and they can be kind of aggregated around to produce courtyards and to produce kind of larger or smaller clusters that interface with the landscape. Here's some of the kind of layouts that the system that we played with that the system can provide. And here in this plan, you could see how the house is divided up to take care of the temperate Balinese climate and participate in the kind of indoor-outdoor living that's traditional here, where we have this porous collection of indoor spaces arranged around extensive outdoor spaces, but kind of more or less clustered around a kind of public courtyard where you can have outdoor dining and cooking, and a private courtyard around which the bedrooms are ringed. Image of the model with the roof on and off. And finally, rendering that tries to show how the units come together to form this whole where the surrounding landscape is encouraged, the rice paddy landscape is kind of encouraged to flow into and out of the living spaces. So this is we finished up master planning on this project, and it's going through permitting now. We're waiting for a while for a change of government in Bali. But the new government is in place, and so we know who to bribe, and we hope to get this thing underway and break ground this year for partial completion sometime next year. Okay, finally, this is a competition that we won in Gabon, West Africa, for a civic space within a park in the capital city of Gabon, Libreville, Gabon. And the reason we won this competition is that we proposed to transform the ruins of an old theater on the site into a new outdoor theater for the city. So we're reusing the stage and the seating, and the old theater is perched on a hill with a commanding view of the city, and with a view to the national park. Gabon has one of the largest, kind of most extensive by area national park systems in the world, in a very kind of dynamic ecosystem. So we just kind of kept for the project, we just kind of kept we kept the stage and we kept the seating, and we took down the walls and opened up the performance space to the outdoors. And covered it all with a new canopy that you can see here. The canopy is an aluminum structure clad with Gabonese hardwood. Gabon has amazing hardwood resources, and they also have trees that grew up to resist the kinds of termites that occur there, so which is very important. The old building built by a Yugoslavian construction company was riddled with termite holes, and Yugoslavia didn't even make it. doesn't even exist anymore. So here in this section, you can see the site with the old seating and the stage poking out over this hill into a palm forest down below at the bottom of the hill, and the new canopy that shelters the performance space, but also juts out over a new public plaza that knits together the performance space and a banquet hall and the new convention center that's being designed by Work AC, another New York firm. The canopy itself is made out of a single 2-meter, kind of unit. Again, a kind of single building element. It's a 2-meter wide aluminum extrusion that forms a stress skin structure that's clad in this native Gabonese hardwood. So here's the site plan with performance space, this new public plaza, banquet hall that we're also renovating, and a covered walkway, which we also designed, that leads to the convention center over here. That's being designed by Work AC. So it's a kind of new government-owned kind of arts, entertainment, and convention complex, where they're trying to diversify their economy and try to get away from economy based exclusively on the exploitation of natural resources, oil, and minerals. So this is a building system with only one part. So instead of the usual hierarchy of building elements like columns, beams, etc., it's made from only this single extruded element arranged into structural panels that are essentially hinged together on site. It was important that we came up with something that where the specialty labor could be done off-site, delivered to the site, and essentially hinged together on-site with minimal equipment and minimal expert labor. So here's that. Here's that extrusion. It's an extrusion just like a storefront window extrusion, except very large. It's 2 meters wide by 45 centimeters high, and pieced together to form these panels. So this is a diagram of the assembly process, where you have each element spirals around other elements, leaning on one another around a central column to produce a panel. And then these panels spiral around a central column to produce a kind of a reciprocal structural arrangement where each element of the structure acts to hold up its neighbor in a closed kind of loop. So this idea of building with a system with only one part abandons the typical hierarchy of building elements that you would find in a conventional building, maybe like this one, where columns lead to beams and beams lead to joists, and joists hold up skins in a kind of very hierarchical arrangement. Instead, this is made up of only a single extruded element and configured into a meshwork of sorts that's still capable of surprising spans. So this project is in the bidding phase, stalled a little bit until the price of oil recovers, but we're still optimistic. And we think that this will probably be our second or third building. We'll see how the Bali one goes. But this is how this is kind of where we are on our trajectory. So to just conclude, if this is the age of makers, we like the idea of being ruiners. We atomize the component of a project in order to build them up into something we wouldn't have been able to build before. We do this to disrupt our ideas of what that thing should be in the first place. This idea for an architecture that needs to be reformed after falling apart is kind of what we're about and what we will continue to investigate. Thank you. Is one of our goals to integrate structure and form into one? Absolutely. Yeah, I think it's, to put it another way, I think we like to, we like to encourage the kind of generative nature of our projects. And so working with structural ideas, working with structural constraints, other kinds of constraints, we try to investigate those in a rigorous way, break them down to their kind of essential qualities, and try to build the project up from there. So that in that way, I think you arrive at a more integrative project if you start kind of integrative from the beginning, rather than try to merge things, let's say, down the road in the design process. How can computation conserve the kind of communal qualities of a project? Well, I mean, it doesn't do it automatically, but I would say that that this approach we have of kind of approaching a project, atomizing it into its kind of smallest constituent parts, and building it back up includes things other than, say, form or structure, but also includes things like program and ritual and people. I mean, in the case of the baskets project that we did with Terrell, the kind of communal aspect of the activity of weaving a basket, or the process of weaving a basket, is a communal kind of process. It's a very kind of social process, and it's an algorithmic process where you kind of sit around and you talk to one another, but they also kind of sing songs while they're weaving, because the weaving is a very kind of rhythmic process, and the songs are, in a way, a kind of sympathetic rhythm, and also a kind of instructions for weaving. And it was our kind of revelation that these kinds of ancient material practices are also communal practices, and are also kind of algorithmic design practices. So looking at it from that perspective, what we're really doing when we're designing is kind of connecting these universal themes, say, like algorithms and geometry, math and science, to very kind of everyday activities of our lived experience. And so design is, in a way, kind of communing between these two worlds all the time, between these universal things and these very specific and kind of lived kind of experiences. Yeah, we're, like everybody else, we're interested in the way that that machine learning is kind of changing the way that that we live our lives, that we move through the world, and how they might impact our design process. The way that I'm thinking about it is, so if the history of the 20th and early 21st century was about humans designing an algorithm to become a computer program to execute a certain task, AI will be about kind of turning that on its head, where the machine is going to learn how to, the machine is going to learn how to execute a certain process. So all we will do is kind of input data, and the machine will process that data, and what comes out on the other side is the algorithm. So that's a really exciting proposition, because you don't have to, then you're not limited by the knowledge that you have in hand here to kind of train the computer to execute the process in the best way that you know how right now. You will simply kind of shove data at the machine, and the machine will learn how to process that data, will learn how to execute that activity, and will also learn from that execution and continually kind of evolve faster, better, more efficient algorithms until they take over the world and they don't need us anymore. But that's a long way down the road. Yeah. Well, it varies on a case-by-case basis, but essentially the strategy is to kind of put the intelligence in at the front. So, like, use the skills that we are all developing, and use these kind of advanced tools that we all have access to now to kind of put the intelligence in at the front. Like the project in Gabon is a good example. Working with AKT, I mean, yeah, you have to have, I guess, it helps to find an engineer that works in a sympathetic way to an architect, but you know, those kinds of people are increasingly common, and the role of architect and engineer is becoming increasingly overlapped. So, you know, it's kind of very kind of imaginative, rigorous, and rigorously tested stress-skin formulation that we came up with Daniel for the Canopy here. Once we've kind of figured that out, it can be executed in very conventional means. So, like a really kind of typical and conventional extruded aluminum piece, only one unit that can be assembled face-to-face, bolted through face-to-face, using very conventional means in a shop, and then shipped to site and put together by people who are really not used to putting up kind of innovative structures. Part of the rationale of this project was to start to build up a kind of local building culture in Gabon, something that they don't have now, and it's not there now. But hopefully through this suite of projects, it can start to arise. The other thing that this gives you is, if you spend the time to front load the work and the intelligence into the system, then not only can the execution be more or less conventional, it can be efficient, and you can, so in a way, it can be efficient, and efficient means cheaper. So you can get away with more design than maybe would have been allowed otherwise. Yeah, these patterns, these kind of alternating stripe patterns that seem to occur again and again in different modes of Gabonese design. I mean, we're certainly looking at that at the same time that we're looking at kind of material solutions and structural solutions and programmatic solutions. It's all kind of a soup, and I don't know. I'd be hard pressed to say exactly what kind of decision preceded another. But yeah, we want these things to resonate with their place, and we want to do that in a kind of in something other than like a superficial fashion. We want it to be kind of resonant with the place, and I don't know. There's no formula for that.